So I'm going to give a very simple presentation, but it's an overview, kind of for the transportation. What are all the pieces? What is the transportation system? What are the general strategies and fuels and vehicles? And then there's going to be people following up. Tomorrow, Lee Lind is going to get into the details of biofuels, and we had an hour-and-a-half discussion last night and did not come to a resolution, but he's going to do his best to come to a resolution. You know, Joan will be talking about hydrogen, and Inez will be also be giving some broader context in addition, and going into some of the details as well, elaborating. So the first thought I had is, for everything we're talking about, I think it might be useful just for framing a lot of the discussions, is this idea of thinking about the future of technology and technology adoption and commercialization. There's basically, you can look at it in three ways. There's the technology, there's the markets, the consumers, and the policy that's guiding it. And for all the different sectors and technologies, the relative importance of these will be more or less. But I think, and I know this meeting is focusing on technology, but technology is in many ways a function of what consumers want and are willing to pay for, and to what extent the government or policy is guiding it. Because a lot of what we're talking about is the public benefit, the public interest. And there's a lot of externalities, there's a lot of market failures. And so policy, certainly with greenhouse gases, plays a huge role and will for probably forever. So I just leave that up there, and we can come back in our discussion today or others when we talk about it. So kind of think for the transportation sector, we can use what's sometimes referred as a Kaya identity. Lee Shipper, that many of you know, really promoted this a number of years ago. But it's a good way of thinking about the different strategies going forward for the transportation sector. So I put it in terms of the units, but VKT, vehicle kilometers traveled, that means how much activity, and this is cars, trucks, everything. So the amount of activity times efficiency of the vehicles, miles per gallon, liters per kilometer, and the carbon intensity of the fuels that are being used. And so what I'm going to talk about, so we can, everything we do in transportation, it's very useful as a way of framing it to bring it back to this. So no one else is going to talk about vehicle usage, I don't think. So I'll spend just a little bit of time on that, even though that's not technology per se, but there are a lot of technologies that could be brought to bear that affect it. Efficiency of vehicles, which evolves into, bleeds over into the powertrain technology and the fuels you're using, and then the carbon intensity. So Joan will be talking a lot about, she'll be focused on hydrogen, but really so using this carbon intensity framing to think about it. And Lee will be talking about biofuels. So this is the transportation sector for the United States. And that is that in terms of greenhouse gases and energy, this represents both. A little over half is for light-duty vehicles, cars and light trucks, SUVs, pickups, minivans. Air transportation is close to 10%, 8, 9, 10%. Trucks are about 20%. And this includes both medium duty and heavy duty. So as we think about trucks, though, we can think about trucks that are used for local use and trucks that are used for long haul. And they have very different attributes and very different needs. We've got I put ships, trains, and transit all together because it's a small chart here. But in the United States, ships are probably about 4%, trains about 2%, transit about 2%. And then off-road, which we almost never talk about, off-road transportation is another 10% or so. And this is agricultural equipment, construction equipment, and a lot of other portable equipment that's used, that's more mobile. So let's try to look at, okay, and so one other context for this is, so this is United States. If we were looking at, let's just say the rest of the world generally, trucks would be a bigger share. Light duty vehicles would be a smaller share. You know, in the United States, we have 8 vehicles for every 10 people. Europe is about 6. Japan is about 5. China is much less, but like Beijing is already up to 2.5 or 3 vehicles for every 10 people, the city of Beijing. So it kind of indicates where it could go. Most people think 5 or 6 per 10 is probably the upper limit that you might expect under any kind of normal circumstances, and United States being kind of its own outlier. Ships, if you look at it internationally, is bigger. You know, here it's about 4%. Partly it's how do you count, you know, which part is allocated to the United States, which is elsewhere. So ships would be more, globally it's probably 8% or so. Trains are pretty small. Transit would be more, significantly more in other countries, but it's still kind of small. So I put this up here to frame it because, well, Nate told me that whatever I say, he's going to ask me, what are we going to do about planes and trucks? So I'm going to get to that. The light-duty vehicles, we've actually heard indirectly quite a bit about them already. I think we have pretty high levels of confidence that with light-duty vehicles, electrification will do most or all, can cover most or all of the vehicles. And when I say electrification, I mean battery electric vehicles and hydrogen fuel cell electric vehicles. And we get into some debates about, at least in the first 80%, whether there's a role for plug-in hybrids. I think for 80% definitely yes. And I would say for 100% decarbonization also, because we have our plug-in hybrid, like the new Volt that General Motors puts out. It goes about 50 miles on electricity, and at least so far, people are using that for about 80% of their mileage is electric miles. And if you had a few more chargers out there, if people were a little more responsive to signals about using electricity, you could even go a little bit above 80 probably. And then you could have zero carbon biofuels that could be the rest of it. So plug-in hybrids certainly play a role through this century. And there's a question, how much as you get further along. But in any case, generally speaking, electrification will probably take care of light-duty vehicles. It's not going to be simple. It's not going to be easy. Some of us kind of in academia more so presume that it's almost like a done deal. But right now, today, electric vehicles are for sale that are, in many cases, cheaper than gasoline vehicles, when you take into account incentives and how they're discounting the vehicle so much. And even in California, we're only up to 2% market penetration, and the rest of the country is under 1%. So this is not going to be easy or straightforward, but it looks doable. So with Nate's encouragement, I'm going to move on. So trucks, I think we can divide almost in half, where there's a lot of trucks that are used for local deliveries. This includes medium-duty trucks like the UPS delivery trucks and contractor trucks and so on, retail delivery. So about half of that is probably amenable to a lot of the electrification options. Some of them battery, but certainly all of them for fuel cells, running on fuel cells. But then we get the other half, the long haul. So roughly about half of that energy is long haul. And I would note, just actually a few days ago, Mercedes announced that they're going to build an electric, what we call Class 8 truck, the big tractor trailer. But it has a range of 120 miles, and it's meant to be an urban delivery. Now, as batteries get cheaper, of course, that range could be extended. But these batteries, what's that? They're delivering the batteries. And it takes up a lot of space, it's a lot of weight. And even under the most optimistic, projections of battery technology, it's hard to imagine batteries being used for any kind of vehicle that's going more than, for cars, it can go up to about 200 miles easily. But just to give you context, because many of us just just wave our hand and say batteries for electric vehicles. But even if we got down to this $100 per kilowatt hour, which is really aggressive and maybe we'll get there. And you think about it, that vehicle, so like the new Nissan Leaf is something like 30 kilowatt hours, but even that's considered just marginally accepted as a mainstream vehicle. So you're probably talking about, so we'll say, okay, they'll be more efficient in the future. So a minimal is 30 kilowatt hours, $100, that is an extra $3,000. Is that a lot? Is that a little? I mean, I think from a consumer perspective, it's significant. Now, if we have policies to offset it, that's all fine. But now if we get up to bigger vehicles, if you're talking about 70 kilowatt hours, you're talking, even in the best scenarios, we're talking an extra $7,000. And you're getting more limitations of range, because in these bigger vehicles, you got a lot more weight you're moving around. So anyway, batteries could meet half of the truck use you can imagine in the future. The other half needs something else. And we can probably put the other half of trucks and air in the same category. You probably need a liquid fuel, a dense liquid fuel. Well, they're using the best one now from a performance perspective. So what's the next best? And the next best, until someone brilliant comes along with something, is some kind of biofuel, a liquid biofuel. Probably not ethanol. Ethanol has about 2/3 the energy density of petroleum. But you can make a lot of other biofuels that look just like diesel or jet fuel. And Lynn is going to talk about that. I mean, if we go back to hype, underappreciated and overhyped, in many ways, biofuels 10 years ago were advanced biofuels were definitely overhyped. But now they're probably underhyped, underappreciated. So there's cycles to some of these things. And you could almost say the same thing about hydrogen. George Bush was promoting hydrogen in his State of the Union speeches. It was a big program at DOE. Steve Chu came in and he put the kibosh on it. He was very skeptical, even hostile to hydrogen. He used to walk around giving these speeches about you needed these 4 miracles for hydrogen to happen. At the very end, he mellowed out a little bit, and some of the programs came back to DOE. But the automobile companies have maintained a strong commitment to hydrogen fuel cell development through all these years. And Toyota, Daimler, Honda, Hyundai probably the most, GM quite a bit also. And they've had massive programs. I was in the Toyota R&D facility for hydrogen just 2 years ago. They had hundreds you know, they said to me, we can't tell you how many engineers are working on it, but if you want to do a count quickly here, you see half of them right here. They had, you know, hundreds and hundreds of engineers work on fuel cell development. So, you know, one answer to the hydrogen question is also that the car companies seem to believe in it, and that's worth a lot. I mean, if they believe that's an important part of the future, then there's a good chance it's going to be. Now, if no one believes that biofuels is important, it's probably not going to be. And we'll get into the biofuels discussion tomorrow, although I would comment that, well, I'll leave that to Lee. So, okay, so what do we do about, so some kind of advanced low carbon biofuels is the obvious answers. But as we've been seeing, those advanced biofuels have not been making much progress. There's been a few plants built. They're either almost all of them either shut down or not operating very efficiently. The DOE has slowed down, reduced their investment in biofuels, and basically there's no major constituency for it. The big oil companies who are the obvious investors in biofuels don't feel a need to invest. The only policy instrument that is pushing them to do so is the low carbon fuel standard in California. And so they're not investing, and there's really no other, the ag industry doesn't have the resources or the expertise or the scale to do it. No one else does. So it's not happening. So my hypothesis is that if we can create the incentive structure or the policy structure for the oil industry to invest, then I think we'll see these biofuels happening. And there's a lot of ways it can be made. So we got to hope that has to be part of the set of solutions. You know, so to summarize, we're talking about electricity, hydrogen, and biofuels. That's really it. Now we can come up with some creative applications with electricity, like for trucks. On some routes, we could have catenaries. Siemens has been investing in this, where you pick up the electricity right off the road. You can actually have inductive charging. And I would make, so I did want to make one last thought on vehicle activity. And that is vehicle usage in the US, all the OECD countries, vehicle usage per capita on the light duty side has been pretty much flat. It went down for a little bit, it's going up a little bit, but it's kind of saturated. Truck use is going up. But on the light duty, the question is, what's going to happen? Because if we can reduce this by half, it makes everything a lot easier. And this, trucking's more complicated because it's an essential part of your economy. But light duty vehicle use, we could reduce. And there's lots of ways of doing it. I'll just lay out. I would say I put up this word path dependency because there's so many things we could do with the transportation sector as a system to make it much more efficient that we don't do. We could, I wrote a paper a few years ago with actually a guy from Harvard, Richard Foreman, where we just laid out, you could have very small cars that are automated, pods. They get their electricity through inductive charging from the roadbed. You make the road could be very cheap because you just have light vehicles on it. You could even have pods that carry a lot of the cargo as well. Maybe a small little battery for when it goes off the main roads. That system would be far more efficient, save lots of energy, far less greenhouse gases, and it would be far superior to what we have now. We're not going to do it. In fact, even China's not going to do it. No one, even other countries coming along later, are not going to do it. Now, the one thing that we might do is with automation. If we can combine automation with the idea of shared vehicle use, shared mobility, and then electrify those vehicles, we could actually dramatically reduce vehicle kilometers traveled so that we just have vehicles running around. And on freeways, they run in platoons and save energy. They become lighter weight because they're safer, so you don't have to build them with all the crash worthiness in it. And you have multiple riders in the vehicle because you have the Uber Lyft kind of technology, and you just scale that up. So you can come up with considerably less in the light duty sector. On the truck side, it's far less promising in terms of what we can do. So it really does come back to long haul trucks and air, and what are we going to do about it? And you can use hydrogen. You know, Amory Lovins has been bending my ear lately. He's just down the road here. I guess he's represented here about using liquid hydrogen in planes. It's as I think Jack said, that's a real stretch. You know,
we looked at it 10 years ago.
Yeah, it's
tough.
It's tough. So that's kind of an overview, and others are going to elaborate on some of the things I said. Thank you.
Thank you.